Hello everyone, welcome to my channel of Big Boy Physics. From today I'll be starting a new playlist that is 3D rotation. Yeah, probably many of them may have some curiosity to know more about the 3D rotation concept especially because of the J Advanced 2016 rotation problem. Well, I hope that I don't need to mention about the problem. Most of them already knows about it. So in this playlist, I'll be trying to get you to the depth of the 3D rotation involving inertia tensors, all those stuffs. So let's get started. Things to be discussed. First thing is the Chisel's theorem. Chisel's theorem is basically relative motion. You will get it in first row only. Then is V is equals to omega cross R. You have probably studied it in your JE phase. While doing the J advanced problems also you'll come across this. Then this is an important thing, that is the definition of omega vector with respect to lab frame, omega vector with respect to another rotating frame, and all those. Then comes the inertia tensor. Inertia tensor is a new concept which involves another tensor called IXY, IYZ, IZX, all those. Then comes the concept of principal axis, that is, there always exists an axis, orthogonal set of mutually perpendicular axes, such that Ixy is equals to Iyz is equals to Izx is equals to 0. Then comes the how to write angular momentum in terms of omega vector, inertia tensor, all of those. Then we'll be discussing two simple cases where we'll be defining angular momentum. Then we'll be coming up with a question of the day, which will be from David Martin. I am already giving you the source. And then finally I'll give you the HW. I'm also giving you the HW now only. What it will be? It will be JE Advanced 2016 rotation problem P2. That is paper 2. You can take a look. I was doing some mathematics about it. Now here the answer was A or C. Either the answer is A or A and C. I'll also ask you to discuss about why both are correct answers. Okay, so without wasting time, let's get started. First is the Chasles theorem. Chasles theorem is basically very simple. Suppose you have a non-translating rotating frame, okay, and you are in the lab there. Now the it's not a rotating frame; it's any frame, and you have a body, okay. Now the motion of the particle P or the body can be written as the summation of the translational motion. Well, body B is somewhat like this. It's a solid body rather than a particle. Okay. Then, if we consider any point P on it, okay, then we can write the motion of point P as the translation of the body plus rotation of the point P with respect to body. Basically, this is nothing but relative motion. You have the center of mass. The center of mass is moving with some velocity, and with respect to center of mass, it has angular velocity of capital omega. It may not be center of mass also. It depends on the situation. This may be some other defined point. Suppose O. So the motion of point P can be written as translation motion of point P, or that is translation motion of point O, and rotation motion of point P with respect to point O. Basically, it's a superposition principle. Okay, hope you get it. So this is my Chisel's theorem. A very important theorem you must know. Basically, it's a little bit of common sense only. So next, coming to another concept, the second thing is V is equals to omega cross R. Sorry. Now this is my body. I am having a body, and it's rotating about some axis with angular velocity omega vector. Currently, we are not considering about the motion of the omega vector. That is the rotation of omega vector. Another with respect to another vector. We are considering the omega vector to be an absolute vector. Okay. For now, if there may be some angular acceleration, I am not saying, but now we are only dealing with the kinematics rather than dynamics. Okay. Now suppose a body is rotating with respect to point 2, having angular velocity omega vector, and here you have a particle P. One thing to say you that how to determine the direction of rotation using the omega vector. Take your right hand, consider to be the omega vector. Take your right hand, point the thumb towards the omega vector. Now here are your index finger, ring finger, middle finger, all those. Curl your hand, curl your fingers in the direction you can. Probably you can curl it inwards the paper in this situation. Basically, the direction of curl gives you the direction of rotation. So it will rotate in this direction. Basically, if you view from the top, it will rotate in anti-clockwise direction. If you view it from top, okay. So this is an important concept to be understood. Now you can see easily that point P will have velocity inside the page. The velocity vector will be inside the page, and the relative position of point P with respect to point O is given as r vector. Then we say that V vector can be written as omega vector into mod omega. We are dealing with magnitude. We can write it mod omega mod r sine theta. Now, since it's inside the paper, now observe omega vector cross r vector. Omega vector cross r vector, you need to curl your all the fingers this way, so the thumb will point towards the inward direction. So I can write v vector to be omega vector cross r vector, and that's a very important formula. Yeah, this is required a lot of times while dealing with the dynamics also, right? So this one is a pretty simple theorem, I'd rather say, and you already know it from your J knowledges. We have done about the Chesel's theorem and V vector is equal to omega cross r. These two theorems are relatively easy. Then comes the omega vector and the relative omega vector. Yeah, this opens the concept of 3D rotation. What is it? It says that suppose we have three frames S1, S2, S3. Okay, we do not have any lab frame. We do not have any absolute frame. We are considering S1, S2, S3. This may be absolute or not. That is, omega vector may be absolute or not. Okay, and they share a common origin. Okay, now one thing that suppose a particle P exists here in these frames. This is frame 1, this is frame 2, this is frame 3. Well, I am just giving random directions, and suppose a particle P exists in this frame. Consider the particle has velocity or the omega vector omega 1 with respect to s1 vector again, omega 2 vector with respect to s2, omega 3 vector with respect to s3. Okay, sorry. Now what is the velocity vector of point P with respect to first frame, that is frame 1? It will be omega 1 vector cross r1 vector r vector. Now there may be some r1 r dot vector also. I'm not considering. I'm only considering the motion due to rotation. Okay. Now with respect to um, now suppose with respect to any other frame. Now considering S2 frame, suppose velocity of omega vector of S2 with respect to 1 is given as omega 1 2 vector, and omega vector of third frame with respect to second frame is given as omega 3 2 vector. Then we say that omega vector of third frame with respect to first frame is given as omega vector of third frame with respect to second frame plus omega vector of second frame with respect to first frame. This is a very important formula you must know. Now you may derive it intuitively by using just I just said about velocity vector, and with respect to third, you know that v3 with respect to 1 is equals to velocity of third frame with respect to second plus velocity of second frame with respect to first. Just the concept of relative motion will suffice here. Okay. Now you might be wondering what is the use of this concept in 3D rotation. Just a minute. Well, I am taking the same arrangement as J Advance 2016, right? this is my stick, and this is a circular disc. I'm just giving you some insights. Now, what is the thing that, first of all, considering this frame, first frame we are considering is the lab frame. This is S1. S1 is the lab frame. Okay. S2 is the frame such that it's rotating with respect to lab frame, such that it appears that disk only spins. Means if this has the orbital angular velocity is omega vector, then we consider a frame which is rotating with omega vector in the anti-clockwise direction as viewed from the above. Okay, so in this frame what will happen, that it will appear that the disk is just rotating. It will only rotate. Okay, it will only have the angular velocity rather than the orbital. So suppose that it has omega s vector in this direction. Okay, so omega with s2 frame as seen by s1 frame is omega s vector. Now omega of s1 frame as seen by the lab well I did sorry, it will be omega of disk rather than omega s2. Omega of disk with respect to s2 frame will be omega s vector. Omega of s2 frame with respect to s1, that is the lab frame, can be written as omega vector. So I can say that omega of disk with respect to lab frame, that is S1 frame, can be written as omega S vector plus omega vector. So you might have come across through instantaneous axis of rotation through your in your JEE advanced course. Observe that this is a pure rolling disk. Okay, I may not have mentioned this is a pure rolling disk. Okay, now tell me which are the points which are stationary. Now this system has two stationary points. That the first I am marking with red is this one, that is the pivot, and the second is the touching with ground. So the line joining these 2 points, that is P and O, is the instantaneous axis of rotation. Now with respect to lab frame, what we will observe that the whole arrangement at that instant is rotating with with some angular velocity with respect to line OP. Basically, this arrangement will have some angular velocity along the line OP. Okay, and OP is the instantaneous axis of rotation. Basically, the summation of omega s vector and omega vector will point towards the instantaneous axis of rotation. Now we know that instantaneous axis of rotation is pointing towards the positive x direction. But better to say negative, or along the x direction. Better to say along the x direction. So I can say that the y component of the omega vector should be 0. And suppose this is theta. So I can say that omega s sine theta plus omega vector is equal to 0. Now we already fixed that this disk is moving inward the plane of paper. Okay, this disk is moving inside the plane of paper, and this is the center of the disk. That is why omega vector will point towards the upward direction. So according to our convention, the direction of omega s vector is wrong. Omega s vector should be along this direction rather than away from the origin. So this will be the direction of omega s vector. Just writing the vector summation omega s vector omega s sine theta, you'll get omega s sine theta is equals to omega, just to avoid the negative sign. Okay, now you may be asked to find the value of the omega vector along the instantaneous axis of rotation. So what is the magnitude of absolute omega? What is the magnitude of absolute angular velocity of this arrangement will be omega s cos theta, and we know omega s is omega by sine theta, so it will come out to be omega by tan theta. Basically, omega vector is very important to analyze regarding the net angular velocity, and the instantaneous axis of rotation provides us with a large help for this. Okay, so now we take some entry towards the 3D rotation. This one is a very important theorem for solving the JEE Advanced 2016 option A. You can try this again because I have already given you all the hints for solving. So we have already done about the omega vector and relative omega vector. Next comes the inertia tensor. Well, inertia tensor is a little bit mathematical topic. For this, if you don't know about matrices, you must know some concepts about matrices. Those who don't know matrices, you may watch this and just get basic concept. I'll be giving you some ideas of matrices also for solving it. And those who knows may proceed, and those who don't know, I'll be giving you some ideas. I'll be giving just basic formulas of matrices, and then we'll be jumping to a little bit of calculation. Well, I'll not be doing much calculation for this. I'll be directly writing the results of the inertia tensor. Okay, so basic operations for matrices. Now, first thing is that suppose you have a, I consider a matrices A, B, C. How many rows are there? Number of rows is 3, and number of columns are 1. So this is called a 3 cross 1 matrix. Okay. So basically we represent the matrix in terms of a number of rows into number of columns. Addition of matrices. For addition, order must be same. That is, you can add a 3 cross 3 matrix with a 3 cross 3 matrix. 3 cross 1 matrix with a 3 cross 1 matrix. 1 cross 2 matrix with a 1 cross 2 matrix. But it is not possible to add a 3 cross 1 matrix with a 3 cross 3 matrix. This is practically impossible. Okay. And if you have any matrix A which represent Aij, if you multiply with a scalar, you can write it k times Aij. You can also write it to be k Aij. Okay. But Aij represents the element on the ith row and the jth column. Hope you get it. Now we don't need to deal much with addition, all those, but we need to deal with the concept which is known as the multiplication. How multiplication is done? We are considering for two matrices. Suppose one matrix have row 1 cross column 1, and another matrix is row 2 cross column 2. If you want to multiply m1 cross m2, then the condition is that c1 should be equal to r2. Basically, the numerical values of c1 should be r2. Why I'm writing it vectors, I don't know. Basically, I'm habituated with it. Okay, don't mind. So for this multiplication to be feasible, then c1 should be equal to r2. Okay, and how to do multiplication? Suppose a1, a2, a3, b1, b2, b3, c1, c2, c3, and here is x1, x2, x3, y1, y2, y3, z1, z2, z3. Well, understanding multiplication is a little difficult portion. If you don't get it, you can watch some relatable mathematics videos relevant, which you'll get in your 10 plus 2 level only. Matrices multiplication is there, so you don't need to worry. You can watch a YouTube video. For now, I'm explaining. So we need to write the. We can write it as a 3 cross 3 matrix, and it's a 3 cross 3 matrix. We have to deal with a 3 cross 3 matrix, and then the product of a 2 3 cross 3 matrix will be a 3 cross 3 matrix. What will happen is that first we have to write the first element, that is a11. Okay, we'll be multiplying the row of the left hand side matrix with the column of the right hand side matrix and add all the elements. That is, a1 is multiplied with x1, a2 with y1, a3 with z1. So it will be a1 x1 plus a2 y1 plus a3 z1. Okay. Then for writing A2, A12, that is first row and second column, it will be A1 with X1, A2 with Y2, and A3 with Z3. Okay. Basically, it will be A1 X2 plus A2 Y2 plus A3 Z2. Then the third one will be A1 X3, A2 Y3, A3 Z3. You can write it. Oh. Then coming to the second, we will be multiplying the row B row with the XYZ row. Similarly, B1 X1 plus b2 y1 plus b3 z1. I hope you can do the rest of the calculation yourself. And similarly, just we need to repeat the same pattern. Okay. These are some basic things of matrix multiplication. Now another thing you must remember that the product of the matrix, the order will be R1 cross C2. Basically just eliminate this portion. Okay. So the product will be a matrix of order R1 cross C2. Now how to multiply unsymmetrical orders? So suppose you have a 3 cross 3 matrix A, B, C, E, F, G, H, Y, J, and H, I, J, sorry, and this is X, Y, Z. Then do one thing. This is a 3 cross 3 and this is a 3 cross 1. So it will be a 3 cross 1 matrix effectively. Multiply like this: A with X, B with Y, C with Z. So this is the summation and add all of them. Then E with X, F with Y, then with Z, then add all of them, and H with X, I with Y, and J with Z, and add all of them. Okay. So basically, this is the method to multiply two unsymmetrical matrices. Okay. Now we'll be defining something called the inertia tensor. What is inertia tensor? Inertia tensor, before that, before coming to the inertia tensor, you'll get L vector. What is L vector? L vector is written as the angular momentum vector. Okay. Then we write L vector is equals to integral R vector cross omega vector cross R vector dm vector. Now considering a specific axis, a specific set of orthogonal axes, and then opening all the cross products, it will be coming out to be a very big expression. Okay, it will be coming out to be a big expression. Caution, you may try, but I am not giving you the in-depth calculation. You may look at it or you may try it. Just put r vector is equal to x vector plus y vector, x I cap plus y j cap plus z k cap, omega vector is omega x I cap plus omega y j cap plus omega z k cap, and r vector is as I mentioned. Then opening it properly, you will get something, some big matrix, that is integral y square plus z square dm minus integral xy dm minus integral xz dm. Okay, this is my first row. Then minus integral yx dm. Now here will be plus integral z square plus x square dm minus integral yz dm, and finally minus integral zx dm minus integral zy dm plus integral x square plus y square dm. And you'll get L vector is this vector. This is written as the inertia tensor. We put a wavy sign generally above the I and multiplied with omega x, omega y, omega z, and this is a 3 cross 1 matrix. Well, I said already to you that you may try the calculation, it will come out to be very big. So you must take your own risk. Huh. Now we write it more simplified way that tensor, which is written as I matrix, as Ixx, Ixy, Ixz, Iyx, Iyy, Iyz, Izx, Izy, Izz. Now what is Ixy, Iyx? Both are same, but we just define them to be some numbers. You can say we define them to be numbers. When in your JE phase you might have learned about this moment of inertia of a sphere along the x-axis, and it is equal to y-axis and equals to z-axis. Then in this case, you might have seen that if the distance is given as r square dm integral. Now here the r square is written as y square plus z square. Basically it is ixx. Ixx defines as the moment of inertia of the object with respect to defined x-axis. Okay, so hope you get it. This is called the inertia tensor. And proceeding with the next things which we'll be defining. Before that, we'll be looking at a very simple problem. So the problem says that you have a three-axis system. three mutually perpendicular orthogonal axes, and you have a cube. Okay, you have a cube. The length of the cube is a. Now one end of the cube is at origin and the whole cube is in the first quadrant. Basically, it is better to say first octant because there are no quadrants. Now tell me what is Ixx, Iyy, Izz. Now Ixx is equals to Iyy is equals to Izz by symmetry is equals to integral y square plus z square dm. Okay, till now it's okay. Now how to write dm? Dm I can write it as m by l cube dx dy dz. We can replace it by a triple integral and we can see that all the xyz coordinate are independent of each other. So I can just set the limits to be 0 to l, 0 to l, 0 to l. Okay, first we'll be integrating with respect to y, or we can in z whatever u is, we'll get 0 to l, 0 to l. Integrating with respect to y, we'll get l cube by third plus z square l dx dy. Then integrating with respect to y, dz, sorry, dz. Then integrating with respect to z, we'll get 2 l cube by third, uh, 2 l cube, l to the 4 by third, m by l cube dx integral 0 to l, and it will just come out to be another l only. It The final result will come out to be 2 by third ml square. So this is basically my Ixx, which is equal to Iyy, which is equal to Izz. Hope it's clear. Next, we'll be discussing about the Ixy. Now, this seems to be a little new. Ixy can be written as minus integral xy dm, where dm is again m by l cube dx dy dz. Triple integral, of course. And since xyz are independent, I can write it in form of m by l cube integral x dx 0 to l into integral 0 to y dy into integral 0 to l, l z dz, 0 to 1 dz. Just a minute. Yeah. Well, why I have written like this? Because you might have come through your chapter of sequence series in the class 11th. You might have come through this chapter and you might have seen that if you have three independent variable x y z summation triple sigma 0 to n, 0, 0 to n, or you can write 1 to n, 1 to n, and 1 to n. We can write it in form of triple summation. Okay, and since each of them are just alike, you can just write it in form triple x, triple means sigma of x whole cube. This is another way to write. Similarly, we are doing the same. We can write it as in the square form, and finally we'll be yielding with the result ml square by 4 with the negative signs. Okay, so writing the inertia tensor, you will get ml square 2 by third, 2 by third, 2 by third, all the diagonal elements, minus 1 by 4, 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 and minus 1 by 4, all the non-diagonal elements. Okay, hope you get a perfect idea about inertia tensor. So we have done with the concept of inertia tensor also. Now next, discussing about principal axis. Principal axis discuss. Why we are discussing about this principal axis? Principal axis basically yields us Ixy is equals to Iyz is equals to Izx. Okay, and it is equal to 0. This is the concept of principal axis. Basically, we'll be nullifying all the non-diagonal elements, and we will get a very simple expression. If we write angular momentum in this case, we'll get angular momentum to be Ixx omega x plus Iyy omega y plus Izz omega z with direction, of course. It is in the I cap direction, j cap, and k cap. So this is a very important concept. And if the theorem of principal axis says that if you have a system of, if you have any system, random system, there exists at least one solution of principal axis, so that ixy is equals to iyz is equals to izx is equals to 0. Means any system, you can take any kind of system, there will be a solution of principal axis, so that these terms will come out to be 0. Let me give you an example. Consider the previous case, that is the cube. Okay. Now I am considering the axis in this case something like this. That is this is the center of the cube, and the axes are three mutually perpendicular, having the origin at the center of the cube, or the centroid of the cube, or you can say the center of mass of the cube. Now observe that if you find summation xy in this case, or integral xy, both will be almost same. We now observe here in the first of 10, xy is positive. Now consider symmetrical point in the second, third, fourth, fifth, and all those. And if you find the summation, it will come out to be 0. Basically, using symmetry, we can confirm that summation of xy or integral of xy can be written as 0. Same with yz and same with zx. Thus, the non-diagonal elements of the inertia tensor will come out to be 0. And that's a very important concept to learn, because upcoming problem in the QOTD will be applying the concept of principal axis to discuss about the normal reaction in the question. I already gave you few insights. Sorry for the spoiler. Now next thing to be discussed is angular momentum. I already discussed about angular momentum. Now simple cases. Angular momentum will be coming back to it with a problem. Okay. Now getting with some simple cases. So this is my first question. That is, consider you have again a symmetrical orthogonal axis system of axis, and here's my track, that is a circular track, and a bead is rotating or moving on it. Okay. Now can you tell me the value of ixy iyz? In this case, ixy iyz is equals to minus m r square sine omega t cos omega t, where omega t is the angle rotated by it, and here r is the radial distance. This is x, this is y, and this is z. Okay. What is ix? Ix is easy to find. That will be summation of y square plus z square into m, which will come out to be m r square sin square omega t. Similarly, you can get Iyy. You can just use the mathematics and find everything. Right? It will. I'm considering to be uh, whatever you may use. Now, just I need to be sure that I'm doing it correct. Yeah. So here's some problem. You can take this to be x-axis, this is y-axis, and whatever you may take, it's not up to you. I x y, and this will come out to be negative. Now ixx can be written as m r square cos square omega t. Similarly, iyy can be written as m r square sin square omega t. What will be the inertia tensor? Inertia tensor will be sin square omega t, rather cos square omega t, and then the next will be sin square omega t. What is izz? Izz will be simple I m times r square. So it will be just 1. Ixz will come out to be 0, because xz coordinate is 0 for the given particle. So it will be 0 here and here. Minus sin omega t cos omega t, and here will be minus sin omega t cos omega t. Okay, and another mr square will be here. Now observe that this particle has omega vector along the z direction, right? So the above two, that is the x omega and the y omega, will be 0, and omega z will be at the bottom. Getting the product, will have the final product L vector is equals to 0 0 m r square omega z. This is my final result. Hope you get it. Basically, this was a simple one. Now I'll be coming with another case in which the circular motion is shifted above the origin. Okay. Now here's my circle, and here's the z coordinate z0. Now in this case, it's a bit difficult to define all of them. So here my particle is at some omega t again, and this coordinate is r cos omega t j cap plus r sin omega t k cap minus I cap. Sorry. What will be Ixx? Ixx can be written as x, y, and z. Ixx can be written as m r square cos square omega t. In the above, what did I do? Yeah, the same thing we are doing here. So Ixx is equals to m r square cos square omega t. Iyy is equals to m r square sin square omega t. Tell me Ixy. Ixy will be minus m into x coordinate into y coordinate will come out to be m r square sin omega t cos omega t, and another negative direction is there, m r square sin omega t cos omega t with a positive sign. Yeah, here also there it will be a positive one. Okay, because we consider a negative sign while doing the Ixy Iyz. So Ixy is equal to m r square sin omega t cos omega t. What will be Iyy Iyz? Sorry, Iyz will be minus m r square cos omega t z naught minus m r z naught cos omega t, and Izx is equals to minus plus m r z naught sin omega t. Now we are writing everything with respect to the origin. We are defining the angular momentum. Basically, we are defining the inertia tensor with respect to the origin. That is why the net angular momentum will be perpendicular to the line connecting the particle and the origin. Okay, the angular momentum will be perpendicular to the line connecting particle and the origin. Hope you get it. So basically, we will be getting some x component, y component, and z component non-zero here. Okay. Now next time keeping you some exercise for you. You can find the L matrix, the angular momentum matrix in this question. Okay. Now we are coming to the most important, which everyone was waiting for. It is that is we'll be discussing about the QOTD. So this is the QOTD. The QOTD is from David Morin, question number 9.54. The question says about a rolling wheel and then axle. It says that a massless axle has one end attached to the wheel and with the other end pivoted to the ground. The question says that the wheel is rolling on the ground without slipping, with the axle inclined with an angle theta. The point of the ground traces an outer circle with frequency omega vector, that is capital Omega, so that omega vector points horizontally to the right as shown in the instant with the magnitude of omega is equals to omega by tan theta. So this question is an interesting one, and if you see that omega vector is the capital omega vector is pointing towards the downward direction, right? It's pointing towards the downward direction. Hence, my omega spin vector, the spin angular momentum vector, should point towards the out radially out of the origin, and the omega spin is such that this will nullify the vertical component. Hence, we will have a net component along the rightward direction. As said in the question, omega is equals to omega s cos theta, which will come out to be omega by tan theta. You can derive this result very easily. This, I have already given this insight in one of this portion only, in one of these frames. I have given you that omega vector, the net omega vector is written as omega by tan theta. you can look at it and then realize that these two questions are basically same. Okay, so first question was relatively simple. Second question, it's a little difficult one. This says that you have to show that the normal force between the ground and the wheel is N, which is equals to mg cos square theta mr omega square, and this big expression, trigonometrical expression. Let me say you one thing, that deriving this portion is very easy, but deriving this trigonometric one is a little tougher one. You need to have greater understanding of the angular momentum vector. So let's get started. Now tell me one thing, that if I consider this to be the principal axis, this is my xy axis, this is my y axis, and here's my disk. Okay, here's my disk, and this is my x axis, and this is my y axis, as mentioned. In the question, it's saying that we have to assume on using the concept of r, small r, and theta only to derive all the results. Just a minute. Okay, so in this case, we'll be using this as the principal axis, and the z axis is of course out of the plane. You can get it. Here's my center. Now tell me, ixy is equal to 0. Ixy will be 0. Iyz will also be 0, because z component may be positive, but the y component will be negative. And when basically the summation of xy will come out to be 0, you know that integral x dx is equal to 0. The same thing is happening here, right? So ixy is equal to 0, iyz is equal to 0, izx will also come out to be 0. Just be cool and calm and solve the problem. So you have to define the inertia tensor again. Well, in this case, we know that we already have some moment angular velocity, that is omega vector towards the downward direction and omega spin vector towards the x direction. Okay, and we already said that omega spin is given as omega by sine theta. Now, to find the angular momentum, you can use two methods. The first method is using the angular momentum of the center of mass of the body plus angular momentum of the body with respect to center of mass. Well, now here I am only using O as the point to define the inertia tensor and finding the angular momentum. And before finding the angular momentum, we'll be bifurcating all the components of omega. And another component which will come out to be as minus omega sine theta along the x direction. So basically, along the x direction, my omega vector will come out to be omega cos square theta by omega cos square theta by sine theta. And along the minus y direction, it will be coming out to be omega by sine omega cos theta. Hope you get it. Now, next thing to discuss is that what will be my angular momentum. Now, with respect to Ixx is given as mr square by 2 omega x, and Lx will be given as omega x times omega x is basically omega spin. So just multiply with mr square by 2. So what will be my angular moment Iyy? What will be Iyy? Iyy can be found using the parallel axis theorem, which will come out to be Iyy equal to mr square by 4 plus ml square, where L is the length of this rod. R by L is equals to tan theta. So L will come out to be R by tan theta ml square, and just substitute it. You'll get R square by tan square theta. And just we need to put all the values. You'll get Iyy to be mr square by 4 plus mr square by sine square theta into cos square theta. Okay. What will be omega yy? Omega yy just multiply with omega cos theta. You will get mr square by 4 omega cos theta plus mr square omega cos cube theta upon sine square theta. Hope you get it. Now we need to just do some more calculations. coming out to be omega cos theta. Hmm. Now what will be my, and now I need to basically focus on the rate of change of angular momentum also in this question. So this will come out to be Lyy. This way is my Lxx and this is my Lyy. What will be my component of, basically if you consider the vertical component will remain same. Okay, the direction of the horizontal component will basically change. So it will be Ly by sine theta multiply with the sine theta. You will get mr square omega by 4 cos theta sine theta plus mr square omega cos cube theta by sine theta. This is Lyy along the x direction. Similarly, what will be Lxx along the x direction? Just multiply with a cos theta, and we already got uh, Lxx and omega x. I say that omega cos square theta by sine theta, cos square theta by sine theta. I already said that you have to multiply with the cos. Just multiply with the cos theta. You will get mr square omega cos cube theta by 2 sine theta. Okay, hope you get it. So basically the angular momentum along the x direction will be 3 by 2 cos cube theta upon sine theta plus 1 by 4th sine theta cos theta into m omega r square. Now what will be my rate of change of angular momentum? Rate of change of angular momentum, just multiply with the rotating vector, the vector which is responsible for rotating this angular momentum vector. Multiply with omega. You will get m omega square r square. And this big trigonometric expression, I don't want to talk about it also. It's too big. This is my Lx. Observe that omega vector is downward direction. So Lx will rotate towards the positive x direction. Now the normal reaction is providing us a positive torque towards the z direction. So basically it is equal to n into, you have to find this horizontal distance x x, and we know that x can be written as r by sine theta. You can write it r by sine theta. There will be some tension force since we are considering the angular momentum with respect to the origin. So the tension force on at the origin, the torque due to tension force on the origin will be zero. And one thing I must inform you before solving it, that these massless rods can only exert tensile force. These can only exert tensile force. There is a very low chance, means there are very few exceptional problems, even though they most of the times goes bonus or are the declared as the wrong problems. In those cases, it said that there are some force along the longitudinal direction, or there is some stress force which actually does not occur in case of thin rods. That is why we do not consider any stress force here, or the bending torque, and which already said it's a rigid rod, so why there's a question of bending torque. Another torque will come in the negative z direction due to the mg component. Okay, and we know that this is r cos theta by sine theta. Just multiply with the cos component, you will get this to be r cos square theta by sine theta minus mg r cos square theta by sine theta. A little bit more simplification, cancelling all the r's, and then you'll get n is equals to mg cos square theta plus m omega square r into 3 by 2 cos cube theta plus 1 by 4 sine square theta cos square theta cos theta. So this is the expression of normal reaction, and if we see the solution, yeah, we get the same result. Basically you can realize that this expression was a little bit difficult to find. We need to define the tension, we need to know the concept of tensor of inertia. Another method is there, just to find the angular momentum with respect to the center of mass, and the summation with the angular momentum of the center of mass of the body with respect to the origin. This is another method. We can do it in the same way, but this inertia tensor actually relieves us a lot from much more calculations. So hope you get it and enjoy this video. And yeah, I almost forgot about the homework. The homework is JEE Advanced 2016 problem of rotation. I hope you know about it and you can easily find it. From paper 2, I am also giving you the location of the paper, which paper this question is taken from, either paper 1 or paper 2. Well, you will see that the answer is given A or AC. A or A and C. Now you have to tell me why C is given as an optional answer. A you can find very easily. Okay. Yeah, for more hints, I can say that I am talking about this question. Here's no rod and here's a rod. It's rotating about this. You have to discuss about the options. You have to now. My homework question also says that why C is given as an optional option. Why C is an optional answer? Hint is rotating frame and translating frame. Hope you enjoyed today's video. Thank you and have a nice day.